Hi, and welcome to It's Not Obvious Java Edition. Specifically, today I will be talking about if statements and all the various ways that you can do if statements. Specifically, we're going to begin by talking about Boolean expressions, then we'll talk about if, else if statements, and how to combine all of those. And I will also be revisiting how we can do user input using the if statements. I highly recommend that before you begin this episode that you've watched my previous episode on variables and user input because that will help you understand what's going on in this episode. As always, this episode is primarily intended for my CSS 142 students at the University of Washington, specifically in the Bothell Campus, and for anyone who is new enough to programming that you haven't yet worked with if statements or if the logic behind if statements is a little bit confusing. All right, so who am I? If it matters, I am currently a part-time faculty at the University of Washington, and during the day, I'm also a software manager at AWS Kumo in Amazon. Now, if you're interested in finding out more about me and connecting, definitely find me on LinkedIn and connect with me there. Would be happy to continue a conversation about the software industry there. All right, before we continue any further, I want to answer the question, is this programming? And the short answer is yes. This is the beginning of a much more complex program that allows you to respond to multiple possibilities and have the correct behavior based on different input. Okay, so if you think about the PET model, the problem solving engineering tools and terminology, this is the beginning of the engineering part of the video episode series on Java programming. We're still going to focus a lot on tools and terminology at this point in time, but this is really the beginning of the engineering part. Okay, so let's talk about Boolean expressions. Remember that Boolean basically means that the value is either true or false, and remember that expressions allow you to use operators, in other words operands, with values to result in a new value. What does that mean? So if you think about 2 plus 2, for example, the operator there is the plus sign, and the two values are 2 and 2 on the left and right hand side of the operator. And 2 plus 2, of course, is just 4. So you have 2, a value, plus the operator, another 2, which is another value, and that whole expression altogether becomes the value 4. We also have operators for comparison. We also have operators, what's called the logical complement operator, which just means not. And as you expect it to be, there's less than or equals to, greater than or equal to, and greater than, and equals. And this exclamation equal sign simply means not equals. You can also use the exclamation sign on its own to mean not. And basically what that means is you can use it in front of any expression that becomes true or false. And if the expression becomes true and you put a not in front of it, not true simply becomes false. And not false, of course, becomes true. Okay, why would we ever want to use that? We'll explore that as we go on. There's also the possibility, and in fact, you will often frequently have to combine Boolean expressions. I will touch on that a little bit for this episode, but I'm not going to focus on it that much. Remember that Boolean expressions typically are intended to be true or false, and so the recommended Boolean variable naming convention is to say is blah. And as a reminder, variable names are arbitrary, so you can name it whatever you want. This is just a recommendation. Okay, so if you want to know more about the nuts and bolts of things, specifically when it comes to operators, you can actually go to this link. And if you open it, you get to this Oracle website, Java documentation, and Oracle are the people who created Java. So this is the official documentation for how Java works. And it talks about the relational and equality operators here. Gives you some demonstration in terms of how that works. And also, if you go a little bit further, it gives you the conditional operators, the and or, that allows you to combine Boolean expressions. Okay, so let's talk about the if statement. The if statement basically says if some Boolean expression is true, do blah. It can stand on its own, it can use Boolean values directly, or Boolean variables, or Boolean expressions. And the body of the if statement is executed only when the Boolean expression is true. If the Boolean expression becomes false, the body of the if statement is skipped. Okay, and inside the body of the if statement, you can do any statements at all. So anything that you want. This can be also a nested statement. In other words, you can have an if statement instead of another if statement. Why would you ever want to do that? Well, there are some circumstances where you might want to do that, and I'll demonstrate that as we go along. You can also have as many if statements as you would like. Okay, cool. So now it's time for a demonstration, and as always, I'll open Bluejay. Bluejay is an IDE that we typically use for teaching CSS 142 at UW Bothell. If you're using a different IDE, you're more than welcome to, but for the purposes of demonstrating this to my students, I'm using Bluejay. As always, we begin by creating a new project. And remember that project names can be anything you want, completely arbitrary, and you can also have spaces inside of it. So let's say if statement demo. And then you're going to also need a new class that allows you to write code so that the code can be executed. So if we click on new class, remember that class name can be arbitrary also, but you cannot have any spaces inside of it. So I'll just say example. Bluejay, unlike other IDE, a lot of times will provide some basic information when you create a new class. At this point in time, we don't really care about this. This is a block comment that we can get rid of. And then this is an example on how to design a class, which right now we're not there yet. We're simply going to be deleting all of this, and instead we're going to do public static void main string array args, and that allows us to create a starting location, kind of like a starting paragraph for our program. Now, why specifically public static void main? Not going to go over that in this episode. Just understand that for now, this is how you're going to be doing it. Later on, we're not going to rely on public static void main quite so much, but for now, we're going to use this method. What are methods? That's going to be in a future episode where I will go over and break down each of this component and what it means and why we need it. But for now, let's begin just by doing system out println hello world. And this is just to make sure that the program works the way we expect it to at a very basic level. Okay, so we can compile, we can run this, and we can see that it prints out hello world. So we can have some confidence that this is working the way we expect it to so far. Now, when it comes to if statements, we begin by saying if and some Boolean expression. For now, let's just say true. And we have a block statement that begins with the open curly bracket and ends with the closing curly bracket. And you can do whatever you want in here. Let's say system out println. It's true. What's true? I don't know just yet. We just know that it's true. Okay, we can compile this, we can run this, and now we get the message, it's true, because the condition over here, the Boolean expression that is given in this parentheses is now stated as true. If we mark this as false, if false, we can compile this, we can run this, and nothing happens because nothing gets executed over here, and because the condition in the first place is false. All right, so let's play around with this a little bit more. If true, we compile this, we execute this, and we want to say that it's true. And then what if we were to say if false, we'll say system out println it's false. Now, if you're anything like me, you might be thinking that it should print out both it's true and it's false, because here the statement is true, we should print out true, and here the statement is false and it should print out false. But that's not how the computer works. The body of the if statement, this statement here, is only executed if the condition in here is false. So now you might be thinking, well, I mean, if that's true, then you're never going to be able to check if it's false, but that's not true either. Okay, so what does that mean? Let's think about it this way. Let's say if we were to have a Boolean expression, and let's say is true equals true. And instead, we put the statement here is true and is true. Okay? Now, this compiles, and right now is true is by default set to true, and so in other words, is true if is true is just true. We execute this, and all of a sudden we get both is true and is false. But that's really weird, right? It shouldn't happen that way because is true right now, and we shouldn't be able to print it's false. Okay, well, what happens if we say that Boolean is true is actually false? So it's not really true. The value inside of it is false. All of a sudden we go back into the state where nothing is printed because this is the same as saying if false and if false. That's why both of these are not executed. So now you might be thinking, well, how do we get to the point where we check these two conditions where is true or false? All right, so how about this? If I were to do if is true equals to true, we'll print true. And if is true equals to false, we're saying it's actually false. It's truly true. And it's actually false. Okay, so we'll compile this. And we'll run it. And here, because it's still at false, it skips this one. False equals to true is not true, it's false. So this whole expression becomes false. So it does not print this, it skips this. False equals to false is true. So it prints out the statement it's actually false. And if we were to exchange this to say Boolean is true equals true, compile, run this, and we get it's truly true because now we have true equals to true, and we print out it's truly true. True equals to false is false, so it doesn't print this one out. Okay, so I hope that's not too confusing. Remember again that variable names are completely arbitrary. It's anything you want it to be. So we can even say Boolean x. And now we're saying if x equals to true, it's truly true. And if x equals to false, it's actually false. Compile this, run this, and we get it's truly true because right now x is true. And if we say false, we can compile this, we can run this, and we can say it's actually false. All right, so that's just the if statement. What kind of other operators can we use over here? What other Boolean expressions can we use over here? Let's explore with it a little bit more. Let's say if we were to have another if statement, if 3 less than 4, system out print line 3 is less than 4. Okay. Compile this, run this, and we get 3 is less than 4, which is kind of like, yeah, obviously, clearly 3 is less than 4. Now, if we change this and say 3 is greater than 4, we run this, and we don't actually get 3 is less than 4 because 3 greater than 4 is false. So if false, nothing happens. This, again, is only executed if this condition up here is true. Okay, so let's experiment with this some more. 3 greater than or equals to 3. Compile, run this, and we get 3 is less than 4, which is a true statement, but that's not the same as the condition over here. Now, the condition over here that allows this to be true is 3 is greater than or equals to 3, which is true. 3 is greater than or equals to 3. And because of that, it prints out the statement 3 is less than 4. But keep in mind that this message over here has absolutely nothing to do with the condition that you put here. Now, you can also nest if statements. In other words, you can have if statements instead of another if statement. So let's say if I were to put this if statement inside of this other if statement, and by the way, a neat trick you can do is you can go to edit, auto layout, and it puts everything into the correct indentation, which is really nice. Saves so much time and makes your code look a lot cleaner. Okay, now what this is saying then is if we were to get into this if statement and we were to run the Boolean, then we have another if statement that that is executed. When we run the statement, then we run another if statement. Okay, So let's execute this, and we get it's actually false, 3 is less than 4, cool. And if we change this to true, compile this, run this, and we get it's truly true because the only thing instead of this if statement is this statement to print out it's truly true. This other if statement, 3 greater than or equals to 3, is inside of the other if statement, which, because x is true, true equals to false is false, nothing in here gets executed at all, even though this if statement in here, 3 greater than or equals to 3, is true. Because it skips everything inside of this if statement inside of this one does not get executed at all. Okay, so let's explore another thing. There is if-else statement. Now, the way you want to think of this is if the Boolean expression is true, do blah. Else, otherwise, do this other thing. If must come before else. Else cannot stand on its own. You can also only have one else statement block, period, for every if statement. Okay? Which means that you can have multiple if statements, and those if statements can have its own else statement block, but every single if statement block can only have one else statement block attached to it. Right. So nesting can also happen in either the if or the else statement blocks, and this is an alternative to multiple if statements. And of course, the question is going to be, what is the benefit? Okay, so let's go back to our code. Now, at this point, you might be thinking, hey, Hansel, isn't there a better way of doing this? Isn't there a better way of checking to see whether the statement is true or not? And you would be correct. Instead of if x equals to true and x equals to false, what we can do is simply change this to else. And you'll see also that there's a slight difference that happened. Earlier, you have two separate blocks. You see this where it's this grayish purple color thing, and you have this block on its own and this block on its own, but the moment you change it, instead of if, you convert it to else, it combines into one big block, okay? Which means that this is now considered as one whole statement. And now you can say if x equals to true, print this, otherwise we print this other thing. Okay, so let's try this. If Boolean x equals, well, if Boolean x is true, we compile this, we run this, and we get it's truly true. And if we change x to false, compile, run, we get it's actually false, 3 is less than 4, which is actually kind of a confusing statement if you think about it. Is it saying that the statement is false, or what is it saying? But as you can see, the if statement is executed only if it goes into this else. We can also remove this if statement from else and put it inside if, compile this, run this, it's just going to print it's actually false. We can turn this to true, compile, run, and we get it's truly true, 3 is less than 4. And if we really want, we can also have something in here, exactly the same, two different if statements that's inside of the if block and the else block, absolutely the same thing. We can compile it, we can execute it, and we can do false and see that it's executed also. But at this point, the question is, if you're going to be doing exactly the same thing inside of the if block and inside of the else block, why would you put it in both? Why don't you put it outside and turn it into a separate if statement altogether? And that is really where the design portion comes in, where you have to really engineer a very particular solution that's going to work as efficiently as smoothly as possible. Okay, cool. So now that you have an idea in terms of how if statements and else statement works, and another thing that you can do here is if x. And because x is either true or false, because it's a Boolean, you don't have to compare it to something else. You can just compile this, you can run this, and we get it's actually false, 3 is less than 4, or we can say true, and we can compile this, we can run this, and we get it's truly true, 3 is less than 4. Okay, great. So let's talk about the next thing, if else if statement. Okay, now the if else if statement needs to be executed in such a way that it has another Boolean condition. It has another Boolean expression inside of it. Else, if true, system out print line, it's actually false. Okay, well, let's see what happens if we do that. We're going to run this, which gets us this. It's truly true, 3 is less than 4. And we get, and let's say if we were to put this as false, compile, run, we have it's actually false, and 3 is less than 4. So far, nothing seems particularly different, but what if we change this Boolean expression inside of the else if into false? Now, x is false, and else if false, 3 is less than 4. Compile this, run this, and we get 3 is less than 4. Now something happened. We know that Boolean x is false, so here this is the same thing as saying if false, and we know from previous experiments that if false, that means this doesn't get executed. Then it goes into the next one. It checks else if false, because this is false, this also does not get executed. Okay, so that's kind of how this works. This goes by order from top to bottom, and it checks the condition every single time, and every time something is true, it executes only that. Okay, so let me explain what that means a little bit more. Let's do if true, and let's do a few more else if statements where all of them are true. So now let's do it's truly true, and let's do it's truly true 2, it's truly true 3, it's truly true 4, it's truly true 5, and I don't know if I really want to go too much further than this. How much more? Okay, 7 is the last one. Great. So it's truly true 7. Now, under normal circumstances, if you're not familiar with how, if you're unfamiliar with how if statements work, you might be thinking, well, you know, in this case, we should probably be able to print out as truly true all the way 2, 3, 4, 5, 6, 7, kind of like that. And in fact, let's just add 1 to this just to make it more symmetrical. But that's not how if and else if statements work. The way if and else if statements work, similar to before, if must come before else if, and you can have multiple else if statement blocks as opposed to only one else statement. But only the first statement block where the Boolean expression is true is executed. Everything else is ignored. Nesting can happen in any of the statement blocks, but basically this is a simplification of a nested statement. Okay, so what happens here? Assuming that this is true, we compile this and we run this. Instead of running through everything and printing out all of the statement is truly true 1, 2, 3, 4, 5, 6, 7, it only prints out the first one is truly true 1. And you can see that it doesn't affect the other if statement, because this whole thing with a whole bunch of else if statements is considered by the computer as one whole statement block. Okay? Now, what happens if we make the first one false? We compile this and we run this. And now we get it's truly true too. Because this is false, we skip this one and we get to this one. Okay? Same thing, if the second one is false, then as you can imagine, it goes to the third one and so on. It's truly true 3. Now, under what condition will we ever want to do this? First of all, while I'm using if false and if true directly in here, that's usually not how it typically works. That's typically not how you would want to create if and else if and such statements, because if you were to use false, then it's always false. If you were to use true, then it's always true. That doesn't really help you. Instead, you might want to use some sort of a condition. Let's say if 3 less than 4, then we say 3 is less than 4. And let's say else if 3 is less than or equal to 3, then we can say something along the lines of 3 is less than or equals to 3. Okay? Or you can do 5 is greater than 4, and you can say 5 is greater than 4, and for the sake of time I'm going to get rid of everything else because I really only need to demonstrate to you on how the if and else if statements work. Compile, run this, and we get 3 is less than 4 because that is the first statement. Now, if you have the expressions to be as it is with actual values, then this actually never changes. Instead, why don't we have an integer that says, let's say num equals to 3, and instead of 3 less than 4, we'll say num, and we'll say num, and instead of 5 greater than 4, we'll say 5 is greater than num. Okay, so we can run this and we get 3 is less than 4 because num is set to 3. And now let's say if we were to 3 is 6, we get 3 is less than 4 again. Why is that? And the reason is because 6 is, let's see, 3 is less than 4, we get 3 is less than 4 from this one over here, which means that everything in here gets ignored. All right, just so that we don't get too confused, or at least I don't confuse myself too much, I'm gonna get rid of that, and we'll say num is 6. Num is 6, 6 less than 4, that's not true. 6 less than or equals to 3, that's not true. 5 greater than num, it's also not true. So let's say if we were to do num equals to 4, what happens? Compile, run, and we get 5 is greater than 4 because num is 4. Now, the better way of doing this is, let's say if we were to do num equals to 3, well, num equals to 3 gets to here. So let's do a couple of things. Let's actually think out some sort of condition that's going to make sense. First, check if the number is positive. Second, check if the number is negative. And then third, check if the number is 0. So let's do here. Num is greater than 0 means this is a positive number. Num is less than 0, and we'll say negative. And num equals to 0, and we have 0. Okay. So we can include this comment here in every single one so that we know what we're doing. And make it a lot clearer to whoever's reading our code to understand what we're trying to do. Compile this, and we run this, and we get this is a positive number. And if we have -5, compile, run, you get negative, because -5 is a negative number. And if we put num is 0, this gets executed, and we do num is 0, 0 is not greater than 0, 0 is not less than 0, 0 is equals to 0, so we print out 0. Okay, great. So as you can see, the way it works is that it executes exactly one statement instead of the if, else, if statements, and it only executes the first one. So say, for example, if we were to have two things that are exactly the same, or three things in this case, -1, -2, -3, and if we were to begin with num equals -5, and execute this, it only ever executes -1, even though num is less than 0 is also true for the next two else if statements. Okay, so I hope that's not too confusing, but basically what I'm trying to say is that if you have multiple else if statements, it's really only going to execute the very first one that is true instead of the Boolean expression, and doesn't execute subsequent ones. Okay, great. Let's look at the next one. So the next one is the if, else statement. And the way you read this is, if the Boolean expression is true, do blah. Else if another Boolean expression is true, do blah. And remember that only the first else if Boolean expression is executed. And then if none of the other ones are true, then else do something else. If must come before else if must come before else, and multiple else if statements are possible, and as before, only the first statement block where the Boolean expression is true is executed, and you can have multiple else if statement blocks, and nesting can still happen in any of the statement blocks. Alright, so let's explore this and see what happens. Now, instead of checking for positive, for negative, and checking for exactly 0, if it's not positive and it's not negative, then it is exactly going to be 0. So we can actually just get rid of this else if statement altogether. Otherwise, must absolutely be 0. Okay, so if we were to execute this and compile and run it, so we get -1, which is this message over here. And if we were to give this 0, we compile this, run this, and we get 0. Now, there's no check at all. It simply says, this is false, so the only thing, if everything else is false, then we simply execute this thing instead of the else statement. Let's do something a little bit more interesting. Let's do first, check if number is positive. Then second, check if number is greater than -10. And then third, check if number is greater than -100. And then else, if it's not positive, if it's not greater than -10, if it's not greater than -100, then we'll say else number is less than -100. Okay, so let's try that. Num is greater than 0. This is a positive number. Else if num is greater than -10, we'll stay negative, but more than -10. And here we can do else if num greater than -100. We'll get rid of this. We'll get rid of that comment because it no longer matters. And we'll say negative, but more than -100. And then else system out print line less than -100. And now we'll do the same thing as before, where we put the comments at the right place to make it easier to follow. cut and paste. We compile this, we run this, and we get negative, but more than -10, because num is 0. It's not greater than 0, but it is greater than -10. All right, so what if we do -10? We compile this, we run this, and we get negative, but more than -100. So -10 is not greater than 0. -10 is not greater than -10, but -10 is greater than -100, negative but more than -100. And then we can also do int num equals -109, compile, run, and you have less than 100, which is the else statement. Okay, cool. So if you want to know more about working with conditionals and working with if statements, there are also a couple of links that I recommend here. And the Java people, the Oracle documentation, actually does have some documentation in terms of the if-then statements, if-then else statements, and you can look at the examples and follow their examples here. There's also other things that are interesting when it comes to what they call control flow statements. There's also the switch statements, and then there's loops, the while and do while statements, and the for statements, which are things that we'll talk about in the next episode too. Now, there's also this other site, this W3C Schools, and we have an example here for Java conditions, working with different operators, working with if statements, and providing various examples that you can try yourself. And in fact, the try yourself is pretty neat because you can just click on this, it opens something, and you can run it, and you can get basically a web compiler, something that behaves like Bluejay, except it's on a web page. Okay, so let's actually apply this into a proper checking of user input. Now, I'm going to go over how we get user input. Again, if you don't know how to get user input, watch the episode user input. Then I want you to keep in mind, as always, that variable names are arbitrary and don't guarantee content, although variable types do have some value and limit enforcements. And we're going to use the if statement to enforce and check for multiple conditions and what happens if the user input continues to be wrong. Okay, so let's go back to all of this. Instead of giving an arbitrary number num, why don't we get user input? Import Java util scanner. So that allows us to create a scanner object. Remember that a scanner object is similar to a scanner, an item scanner, like let's say in a grocery store, that allows you to scan an item and it automatically recognizes what the item is. Okay, in this case, we have scanner S. It's scanning from the system input. Now, instead of int num equals -109, we'll do S equals next int. And let's also include a message before that. System out println, please give us a positive number 1 to 10. Okay, so if we compile this and we run this, and now it gives us this prompt, please give us a positive number 1 to 10. And let's say if we were to give it the correct number, 9. It goes, hey, this is a positive number. You did a great job. All right, well, let's run it again. And this time, let's give it a number that's greater than 10, and let's say 13. It says this is a positive number, and it has 0 check at all in terms of whether it's greater than 10 or less than 1. All right, well, let's try the other side of this. And let's say if we were to give it the number 0, then we get the message negative, but more than -10. In other words, you can guess at this point that there's 0 error checking. There's nothing that indicates that the user is giving the correct value at all. All right, so how do we do that? Instead of checking for positive, greater than -10, greater than -100, and else, we need to do some proper checking. Check if user input is less than 1, error message. and then check if user input is greater than 100, error message. And now putting everything back together, we know how to do this independently. If num is less than 1, system out print line, you didn't give us a number between 1 and 10. And same thing here, we can do if num is greater than 10, we'll use the same error message again. Compile, run. Please give us a positive number. Again, if we give it a correct number, 7, we don't get any error message at all. If we give it a number greater than 10, we get 11. You didn't give us a number between 1 and 10, which is a better message than what we had previously. And if we give a number, let's say 0, you didn't give us a number between 1 and 10. Now you might be thinking, well, you have num less than 1, num greater than 10, and you get exactly the same message. Is there any way to combine this? Kind of. If you were to try and combine it by using else if, and you run this, what ends up happening is that for num is less than 1, let's say 0, you get the error message. And for 11, you get the error message also. Because you have num less than 1, num greater than 10, and it checks this one, and then it checks this one if this one is false. Okay, great. Seems right so far. What if we were to get rid of the if statement and we say else? Compile, run, and let's say we get 5. All of a sudden we get the error message 2, because now it's checking to see if 5 is less than 1. 5 is not less than 1, so obviously it's going to execute this else statement, which is why we need the if statement there. If num less than 1, else if num is greater than 10, we execute this. Now here's the other thing. What if you're able to put everything into one conditional instead of having 2 separate if statements? And this is where we go, if num is less than 1 or num is greater than 10, we just do this. You didn't give us a number between 1 and 10. And the way this works is, let's say if we have 5, 5 is not less than 1, so that's false. Or 5 is greater than 10, 5 is not greater than 10, that's also false. False or false becomes just false. And let's say if we were to do it with negative 15, negative 15 is less than 1. That's true. Or negative 15 is greater than 10, negative 15 is not greater than 10. True or false still becomes true. And that's typically how that works. And let's do one more where we go 70. 70 is not a number between 1 and 10. It goes 70 is greater than 10. So it says that's true, even though 70 is not less than 1. False or true is true. So we execute this. Let's do one last thing where we go else, system out, print line, you followed instructions. Great job. So we compile this and we run this, and now every time we give a number that is between 1 and 10, let's say 1, you followed instructions, great job. And we do 10, you followed instructions, great job. And if we do anything other than that, we get the error message, you didn't give us a number between 1 and 10. Okay, cool. But the problem is this doesn't actually ensure us that num is the correct number at all. So if we try to use num later on, we have no guarantee that it's going to be between 1 and 10. And the question then becomes, what do you do? How can you make sure that num is actually between 1 and 10? Well, the number one thing to do then is to put this inside of a loop. So I'm going to demonstrate a loop really quickly. And let's say we were to do a do while loop. While num is less than 1 or num is greater than 10. Okay? And here, let's see. Right, I need to also close this. And let's make sure that we can use the auto layout and put everything inside of this block. Do all of these things while num is less than 1 or num is greater than 10. And here, if num is less than 1 or num is greater than 10, we say you didn't give us a number between 1 and 10, and we can repeat this whole thing again. Please give us a positive number and ask for num again. Okay? So now if we were to execute this, compile, run. If we were to give it a correct number, let's say 5, you followed instructions, great job. It basically ends the loop. And if we were to give it an incorrect number, 99, it continues asking us for the number. 97 didn't give us a number between 1 and 10. Please give us a positive number 1 to 10. And let's say 57, still not right. Negative 12, still not right. 0, still not right. Until finally we give it a number, let's say 6, then it ends. Cool. All right, so that is a brief introduction to if statements and all the various ways we can do if statements. And as always, my question to you is, what were some things that were obvious to you as I'm demonstrating all of this? And was there anything new that you learned from this episode? Please tell me in the comments if there are also things in this episode that I glossed over that seems to be obvious to me but was not obvious to you. I definitely want to address that. And as always, if you like this episode, please subscribe for more content because I will be providing more videos, more instructional videos such as this. All right, thank you and see you next time.